Hello, Assalamualaikum. We are from Group 5. In this video, we would like to present about fish assemblage as environmental change indicators. Okay, so first, the introduction. As we know, fish have long been used as indicators of environmental change due to their relatively large size and ease of identification. Next, Cushing at 1982 defines resilient fish stocks as those that can withstand environmental change with minimal requirement fluctuations. Furthermore, non-resilient stocks will then be environmental change indicators reacting to primary environmental factors such as temperature, salinity, upwelling, and pollutants, or reflecting an environmental coupling to the food chain or habitat fluctuations.
Now the objective. So what are the purpose or objective that we are doing this experiment? So the first one is we want to assess the response of tinfoil bulbs to various salt level using the 24 hours LC50 value for leader concentration. So the second one is because we want to determine the reading of the fish heart through the movement of the fish operculum. So next one is hypothesis. So what are the hypotheses that we got through the experiment? So the higher the salinity, the lower the dissolved oxygens. So as we can see, as the salinity of the water are increased, the level of the dissolved oxygen in the water becomes lower. This can be proven when experiments are conducted on changes in water salinity. So the change suddenly will cause death to the fish. So this is because when water salinity increase suddenly, the oxygen in the water will decrease, which will make it difficult for fish to breathe.
Result for table number 1, survival rate and opercular rate of tinfoil bulb exposed to various salinity levels. There are 3 different salinity, which is 0, 5 and 15. The unit is parts per thousand, ppt. For salinity 0, the mean percentage of mortality is 0%, which means that no mortality present. Next, for 5 ppt of salinity, the result is same with 0 ppt of salinity. Why? For salinity 15 ppt, the mean is 100%, which means that all the fish are die. Next, for table 2, opercular of tinfoil bulb exposed to various salinity levels. For 0 ppt of salinity, the mean opercular rate is 52 for 10A and 10B. To get the mean of opercular rate, the opercular beat 10 seconds times 6 to convert in minutes. Next, for 5 ppt of salinity, the mean opercular rate is 98 for 10A and 10B, which higher than 0 ppt of salinity. Why? For 15 ppt of salinity, the mean opercular rate is 0 because all the fish in 10A and 10B are died in that value of salinity. For table number 3, recorded water quality parameter, there are 5 different water quality parameters were observed, such as salinity, temperature, dissolved oxygen, pH, and total dissolved solid for 10A and 10B in various salinity level, which is 0, 5, and 15 ppt. For temperature, the range is around 30 until 32 degrees Celsius. In 15 ppt of salinity, the total dissolved solid are higher than 0 and 5 salinity. The pH are strongly alkaline. The range of DO are 6 until 10 mg per liter, which is not recommended for optimum fish health. It should be 5 mg per liter for optimum fish health. Next is the graph bar, mean percentage of mortality and mean opercular rate of tinfoil bulb in each salinity of water. So we have the salinity 0, 5 and 15. So in salinity 0, we got the mean percentages of mortality 0. In salinity 5, we got mean percentages of mortality is 0. And in salinity 15, mean percentages of mortality is 100. For mean opercular rate in salinity 0, we got 52. For salinity 5, we got 19.8, and in salinity 15, we got 0. So here are the results for the mean percentages of mortality and mean opercular rate of tinfoil bulb in each salinity of water.
Next, this slide shows graph linear concentration salinity of water against mean percentage of mortality. So, the higher concentration salinity of water, the higher mean percentage of mortality. It is because when the salinity of the water gets higher, the level of dissolved oxygen in the water becomes lower and it can cause their mortality. Next, the value of egg concentration based on this graph at y of 50% is equal to 8.1.
As a result shown, the fish at 15 ppt of salinity cannot adapt with the higher salinity, which that fish origin from freshwater environment. Higher salinity might cause serious effects such as death to the fish. Meanwhile, fish that live in 5 ppt of salinity has higher movement of operculum compared to fish that live in 0 ppt, which means it required a lot of dissolved oxygen to cope up with stress condition. And then the fish has high metabolic rate if the operculum is moving more quickly. A high metabolism uses a lot of energy. Thus, to gain their energy from pumping oxygen, the operculum cap is opened more quickly. Salinity can have an impact on how fish metabolize their food when they move from fresh water to salinity-rich environment. As a result, typical fish must first adapt to their new habitat by eliminating mucus from their bodies. The osmoregulation system of freshwater organisms is strongly related to the salt level in a medium. Aquatic creatures have various osmotic pressure depending on their habitat, according to Haryadi 2003. Fish should avoid having too little or too much water so that physiological processes in the body take place normally.
So that's all from us. Thank you. Bye bye.